Right, we're taking a look at the midterm review. This is Techmath2. I uploaded the review already onto Blackboard, so you can look at the written version there, but we're going to just walk you through the problems quickly. Number 3 on Chapter 1. And so this is in your packet under the final exam review, and chapters 1 through 10 are covered on the exam. So let's take a look. They want a coterminal angle with negative 750 degrees on number 3. So I'm just going to highlight the ones you should focus on. So negative 750 degrees, remember how this works. Positive goes counterclockwise, negative goes clockwise. So there's 360, there's 720, and then we need 30 degrees more. So there is negative 750, and it's got a reference angle of 30 degrees, because that's 30 degrees past 720. All right, and so we want to do negative 30 is describing it. It's coterminal, but they want it to be between 0 and 360. And so then we have to go the correct way. We have to go here. Let's put in red. We'll go this way around and stop there. So that's going to be basically 360 minus 30 is 330 degrees. And that would be an angle that is coterminal from 0 to 360. Let's look at number 4 on the same page, chapter 1, number 4. It says change 240 degrees to radians. And so we would do 240 degrees. And remember, all we have to do is multiply by a fancy one. 180 degrees is pi radians. So this is equivalent to 1. We put the degrees on the bottom because we want that to cancel with that. And then 240 pi over 180, and that's in radians now. We canceled degrees and are left with radians. And then we have to reduce it. So you divide by 60 top and bottom. And that's 4 pi over 3 radians. And then I made one up for you guys because on the actual test, it's the other way around. So here's a made up one, 4.5. Is change 3 pi over 10 radians into degrees. All right. And so this isn't on your review, I just made that one off. So we're off script there. So 3 pi radians over 10. And we want to multiply that again by a fancy one, but this time we're going to put pi radians on the bottom. So it cancels. And 180 degrees on the top. So we're left with the degrees. The radians will go away. The pi's will actually go away. And so we're left with, what is that, 540 degrees over 10. And so we can definitely reduce that to 54 degrees. All right. Let's look at chapter 2. There's one just like number 1, and that's going to take up whole board. So let's take a look at that. Oh, there's not a little tchotchke up here. There we go. Ooh. Put a little chewy Chewbacca. Peter Mayhew. Okay, let's take a look at chapter 2, and this is problem number 1. 2 vectors of 310 units and 190 units act at an angle of 54 degrees. Find the length of the resultant vector and the angle in between the two. So that's a description. In the actual test, there will also be a pretty picture for you. which makes it a little easier. 310, 190, and then this angle is 54 degrees. I'm going to put a little arrow like this. 54 degrees. Okay. So remember how this works. We want to find the resultant vector. That is, these two forces are acting on this object, an object right here at the same time. Basically, the resultant vector is going to be the diagonal of a parallelogram created. All right, and so the trick is to get it out of polar and into rectangular form. So let's pretend that this is the XY axis right here. All right, so that means this point is super easy to convert. It's 310, 0. That's on the x-axis. And this one's the y, all right? This one is the problem. To find this one, we could go the long way and do all of our sines, cosines, and tangents. I'm going to say, let's go and use your calculator. So your calculator has polar to rectangular x and polar to rectangular y. Remember where that is. That's on second angle. You hit second, you hit angle, and then you go down to find polar to rectangular. And so we'll put in the 190, 54, and you hit enter, and that'll be for x 111.679. So they said round to the nearest whole number. Tell you what, let's just round that to 112. All right, and then rectangular y, 190, 54. You hit enter for that, and that should give you 153.7132222. We'll call that 154. So 112, 154 is what that point is. So now what we do is just add. We add this and this. We add those points. The vertical components and horizontal components get combined, and basically that'll give us the resultant vector, but as an xy. So if I take 112, 154, and I add that to the 310, 0, we're going to just add up the x's, add up the y's. And that's, I like the simplicity of this. It's a pretty heavy duty kind of physics problem, and it boils down to you adding up x's and adding up y's. All right, so that is our resultant vector is 422, 154. But that's not how they want it reported. They don't want it reported as an x, y. So now we're going to take our calculators and go back the other way. We're going to go from rectangular to polar and find the resultant vector, 422, 154, and we're going to go from rectangular to polar, theta, 422, 154, and so that will kick out 499.221 and 20.048, and again they wanted whole numbers. So we're going to say our answer for letter A is 499 units, and our answer for letter B is 20 degrees. So that means this right here, that angle is 20 degrees, and this length is approximately 499. And that would be the resultant vector for chapter 2. All right, then we jump to chapter 6, and we'll do that. So chapter 6. And we got one, there's one like 1, 2, 3, and 4. So, oof, perfect page. So 3d squared p negative 3 over 6d squared p negative 4. So again, we just had a test on this, which you all did very good on. Way to go. Let's reduce the numbers like how always we reduce the numbers. 1 over 2, right? 1/2. D squareds cancel. This negative power pulls that to the top. That negative power pulls that to the bottom. And now we can reduce that. There's 4 on top, 3 on bottom. They cancel 1 for 1. Or when you're dividing like bases, you subtract the exponents, top minus bottom. So we end up with p to the first over 2. And that's that one. Number 2 is the 5th root of p to the third, but they want you to convert it to a decimal, a decimal exponent. So we do this. We say, okay, well, that's like p to the third raised to the 1/5 power. Or you could just do 3 divided by 5. If you don't just want to do that, you can skip all this. This is the y. Why does it work like this? Remember, that's a fractional exponent. And when we have a power raised to a power, we multiply. So we get this. And now we're right back to, you could have just started with that and said, oh, I'm just going to take this exponent and divide it by that 5 and get the answer that way. So p to the 0.6 power is the answer. Number 3, we got the square root of 7xy squared times the square root of 14x cubed y cubed. And so that's an expression. So you can just, they're both under the square root signs. You can multiply them out. You get 98x4 y5. And now we can break it into perfects and leftovers. So perfect. And this is just a little leftover bin, all right? So perfect, a perfect factor that goes into 98. Not a lot of stuff goes into 98. That's going to be 49. And then the leftover bin is going to have a 2, because 49 times 2 is 98. And then perfect, x to the 4th. No x's there. We got them all in the perfect. And then perfect, y to the 4th. And then we stick a y in the leftover bin. All right. And so now, after we got them all separated like that, we can just execute the perfect square. So what is that? That's 7x squared y squared square roots of 2y. And that's our answer. All right. You can do it another way. If you hate that way, you don't have to do it that way with perfects and leftovers. What you can do is you can bust it down into its prime factorization, all the prime numbers. So instead of multiplying these out, let's pull this one apart. This is 2 times 7 times 7. We got 1x there. We got 3 x's there. We got 2 y's there. We got 3 y's there. And now you just kind of do like the prime factorization, or what I call in class the prison break method. So the key to getting out of this prison is groups of 2, but only 1 lives. So a 7 gets out, an x gets out, x gets out, a y gets out, a y gets out. And then this one is stuck, and this one is stuck. So we got the square root of 2y left inside, and then we multiply this stuff out. 7x squared, y squared, square roots of 2y. All right. And then the last one is just a plug and chug. Hopefully that won't give anybody any trouble. They give us q is equal to w over r raised to the a power. And then they make it easy. They tell you to find q given. W is 450, r is 130, and a is 0.4. And so you just plop that into the calculator and round to hundredths. So q is equal to 1.64. All right. So that is Chapter 6. I'm going to do a second video on 7, 8, 9, 10. So look for that.